All right, one May the 4th. All right, let's do this. Boats to save people. Given an array of people, where people I is the weight of the ith person and an infinite number of boats. Each boat can carry a maximum weight of a limit. Each boat carries at most 2 people at the same time, provided the sum of the weight of those people is at... Wait, hold a second, wait. An infinite number of boats where each boat can carry a maximum weight of limit. Each boat carries at most 2 people at the same time, provided the sum of the weight of these people is at most... Okay, I didn't read it carefully. Return the minimum number of boats to carry every given person. Is that knapsack? Something like knapsack, right? So each boat carry at most 2 people. Okay, so it can carry at most 2 people. And you can carry maximum weight. Oh, I think this is greedy. All right, so you basically sort it, and then you say, the number of boats to carry every given person. So for the heaviest person, if the heavy person is heavier, oh, that's not heavier, right? So you try to put a heavy person, and because it's 2, so you try to find the lightest person, see if it fits. If it doesn't fit, then the heaviest person by itself. If it fits, then you always use a light. So yeah, you always pair the heavy with a light. And I think it makes sense because if you don't pair the current heaviest with the current lightest, you say that is not going to be the best way, then whatever other way you choose, you can always swap, right? You say the heaviest with this is the best, right? But I can argue that it will be the same because however, actually it's, hold on. Is it always the heaviest with the current lightest? The heaviest with the current lightest. What if you don't? Yeah, that's the scenario. What if you don't pair with the current lightest? If you don't pair with the current lightest, and you say pair with something else, is going to be a better solution. Then you're gonna pair, like the lightest needs to be paired with something, right? If the lightest paired with something, and you say the heaviest will pair with something else, then that something else shall be able to pair with, yeah, so it shall always be the same. I think this is just greedy. You just sort it, and then you go to the heaviest, and then you just 2 pointers, right? Yeah, I think greedy makes sense. I mean, otherwise, because we want to use the minimum number of boats, right? And then the heavy that has to pair with something, right? And we always try to pair with the smallest. And if there's a bigger version that can be paired, it doesn't really matter, because if you pair with the smallest, then if you can pair with the biggest, you can doesn't pair with the smallest. You pair with something slightly bigger. We can pair with any of those things, right? And my point is you always pair, because you want to have 2, so you can want to pair with one of them, right? So then shouldn't we always pair the largest, right? I think we should pair the largest that you can find, not the smallest, right? So you have from small to big, you can say A0, A1, A2, A3, A4, okay? So this is a max, right? Let's say all of these can pair with this, but we don't want to pair with this, because if pair with this, then it might be possible that this cannot be paired with this. Because this can pair with this, can pair with this, can pair with this. But hold on a second, if this can pair with all 3, then this must be able to pair with all 3. Right? Yeah? So it shouldn't really matter, right? But we want to make use of we want to save the small. That's kind of the idea, right? We want to save the small value. Because if this can pair with these three, then this, because we sorted, so this can definitely pair with these three as well. Which means if I pair this with the smallest, then this can still pair with them. So what's the benefit, or what's the downsides of not pairing with the smallest? Because I can say I can save the smallest for another pairing, which means you're afraid that if you pair with the smallest, then the remaining might not be able to pair. Right? But I don't think it will happen. Because if this can pair with all these, and you say this to pair with this, right? Let's say if it does, like what benefit does it give us? I can say this can be paired with this. Doesn't seem to be more reasonable, right? So we sort it, and then we just go find the first one that can be paired, and that will be the 2 pointers, right? And once we pair, we move this one forward, move this one forward, and then we see if they can pair. And yeah, we paired it, move this forward, then we point into this, then we just keep moving until we find the one that can be paired, then we move forward. That, I think, will work. Basically, we try to find, we put the largest two, we'll put the largest pair into use. And by doing so, we increase chance that the remaining can also be paired. Yeah, so I think 2 pointer will work. And a big value just keep moving left. Each time we find the current biggest one that can be paired, right? We just keep searching. And if it cannot be paired, I just, keep moving down. What if nothing can get paired? Did you have to do that one more time? That's a good question. Don't have a good answer. Or you just binary search. I mean, that can always work, right? Binary search. We sort it, and for each one we binary search, we find the one that will get paired. But then if you binary search, yeah, I still get a problem. So again, why can't we just do 2 pointers? So 1 pointing here and 1 pointing here, right? Once they're good, we just move inwards, and they do get slightly bigger, right? They do get slightly bigger, but the idea is, if A4 cannot pair with this, A4 can only be paired with, you have to pair A4 with something, right? If it can be paired, then what are we saying? What if A3 cannot be paired with this? What if A4 and A3 both can only be paired with 1? What if they can both be paired with 1? Then what's the difference, right? Either A4 get paired, and A3 does not get paired. Because A3 is smaller than A4, right? So this is allowed to get slightly bigger value. Yeah, so I think a 2 pointer going from two, like both ends coming in, it shall be right. Because A4, if it doesn't pair with the smallest, right? If it doesn't pair with the smallest, then A3 can pair. Yeah, because if A4, I say, can pair with all these, then A3 can pair with all these as well. So this doesn't really matter which one to pair, right? Because A3 is smaller than A4. So A4, if I don't pair with this, I pair with something else, then A3 can pair with those. Yeah, I think it should be right. Because if you stand from the point of view of A0, that's the smallest. You want to find the biggest to pair with it. Because if you find something smaller, then you lose the opportunity to pair with this, and this has to go by itself. Yeah, if you actually stand from the smallest point of view, is easier to make it work. So you just sort it. You stand from here, and then you go from the largest, right? And then you just see if the largest can be paired. If it cannot be paired, then this has to be out. So you just go from the first one that can be paired, done. Then you both move inward, and every time you just check. Right? If these two, but what if these two added together is bigger? But that should not be possible, right? That's, hold on. Let me give some 1 and 5. Ah, 1 and 5, 3 and 3. Limit but that's 6. That's also 6. What are you trying to prove? What I'm trying to see is, can I have smallest and biggest, and then something in the middle to actually make it bigger? Yeah, what about this? 1, 4. 1, 3, 4, 5. And let's say limit is equal to 6. Okay. I could, because if I take 1 and 5, then 3 and 4 has to be by themselves. If I don't take a 1 and 5, yeah, it's still gonna have to take all those. Well, how about this? Like, if the smallest cannot, then this has to go, right? So we can eliminate the ones that cannot go with slow. Now we have something. The question is, we have something that can be combined with the smallest. Do we have to combine them? Yeah, I think that's the question. Do we have to combine them? And if we combine them, if we have multiple that can combine, do we always combine the smallest? I think we do combine the smallest, because for all the others it doesn't matter. They will always work. They will always work because this is big. It can combine these smallers, so the smallest can always combine. So yeah, I think it does make sense. We always combine the smallest. We always combine the smallest. Okay, I think I've been more convinced than before. So we basically just say people.length -1, okay? While I is smaller than j. people j plus people I is larger than limit. All right. Then rest plus plus j minus 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 else rest plus equal plus plus and then j minus minus and I plus plus. Right. And then when we get out, we say if I is equal to j, when we get out, actually I can do smaller equal to. We'd have to do smaller equal to. So if they're equal, then the last one doesn't really matter, larger or smaller. Oh. So basically what we can do is for int j equal to people right? Basically say if people j plus people I is smaller or equal to limit, then I plus plus. All right. Rest is always plus plus. Okay. Actually, this should be large equal to I. Okay, let's try this. Oh, that's not right. Oh, because it didn't sort. Okay. Let's see if this one works. Sort people and then greedy. 2 pointers. The largest weight always try to pair with the smallest. Alright, let's try this. Okay, doesn't seem too bad. Do I have a better explanation? No, I think I just went with it.